So see this. This question is asked in IAS. Even though this question is theoretical, they will not ask you such questions in GATE. They might ask you in interviews. Once you clear GATE and if you appear for interview for IITs, they might bring up this question. So, and moreover, I want you to understand how to solve such questions. That is the reason I have taken this, even though it is not really important for GATE. But please watch it. If it is not important for GATE, it doesn't mean that you should skip it. Just watch it once. So see this. Prove that the necessary sufficient condition that the values not all 0 may be assigned to the n variables x1, x2, so on xn, so that n homogeneous equations like this hold simultaneously is that determinant is 0. Okay, I am very sure that you didn't understand even a line of it, even a word of it. I'll just try to simplify the question. What is question trying to ask is prove that. So which means you are supposed to give a proof, and then they are asking about necessary and sufficient conditions. See, whenever a question is given, if they are asking about necessary and sufficient condition, they mean to say about this. If the question is given about P, then Q, necessary means take P and then prove that Q is true if P is true. Understand this. Necessary condition means just see what is given in the question. There will be two conditions given, P and Q. Necessary condition means you should take P and assume that it is true and then prove that Q is true. P then Q, that is necessary. Sufficient condition means take Q, right, and then you should assume that Q is true. On that condition you should prove that P is true. So if P then Q, if you prove like that, then it is necessary. If Q then P, if you prove like that, then it is sufficient. Therefore they are asking about two things. Prove that the necessary and sufficient condition, which means we are supposed to prove both ways, P then Q, Q then P. We are supposed to prove these two. Necessary and sufficient conditions that the values not all 0 may be assigned to the n variables x1, x2, so on xn, so that n homogeneous equations, these are n homogeneous equations, are given. Why are they homogeneous? Because there is 0 here. There is no constant term. Every term in the equation is accompanied by a variable whose degree is 1. Therefore, they are all homogeneous. Okay. Now, it is homogeneous equation. What are the equations? I will be varying from 1 to n, which means a11, a12, so on a1n, and the next one is a21, a22, so on a2n, and the last one will be an1, an2, so on ann. Therefore, the quotients are going to form, the quotient matrix will be a n by n matrix. So I'll just boil down the question. What they are trying to say is, if there are n simultaneous equations in n variables, why n variables, x1, x2, so on xn is given, n variables are given and equations are given. Now what they wanted to say is, if that is going to have a non-zero solution, then determinant of the quotient matrix is 0. So I'll just boil down the question so that you'll understand it, and then let's try to solve both the cases. So first case is, I want to prove necessary condition. Okay, so then what should we prove? We should prove this. We are supposed to prove this. If ax equal to 0, I am just writing this in form of ax equal to 0. If ax equal to 0 has to have a non-zero solution, then this one, det A equal to 0. This is what we are supposed to prove. If det A happens to be 0, then mod Ax equal to 1 has a non-zero solution. That is what we are supposed to prove. Fine. This is necessary condition. And next we have to even prove the sufficient condition. So how I will try to prove this one is, see this. I'll go by contradiction. I'll go by contradiction. What is contradiction is, I'll assume that det A is not equal to 0, then I'll see what happens. This is already given, this is true, P condition is true. See, earlier I told you, right, P and Q are given. Now how can I prove the necessary condition? When P and Q are given, how can I prove the necessary condition? Assume that P is true, and then we are supposed to derive that Q is true. Now what I will try to do is, I will assume that P is true, and then I'll derive that Q cannot be false. Then what can we say? Then we can say that Q is true. That is necessary condition. I hope you are following it. Okay, see this. I'll assume that P is true now. So what is P? Determine this Ax equal to 0 has non-zero solution. Okay, that is already given, which means it has a non-zero solution. Now I'll try to assume that this one is not true. Which means I'll try to assume that determinant of A is not equal to 0. Now we know that whenever determinant of A is not equal to 0, and A in this case is a n by n matrix. Why is this n by n matrix? We have variables and n equations. It is a n by n matrix. When determinant of n by n matrix is not equal to 0, what can we say about the rank of it? Clearly, rank of it is n, right? And we know that when r equal to n in a set of homogeneous linear equations, we know that when r equal to 1, what can we say? R equal to n, what can we say? It has unique solution. It has unique solution, and that solution is equal to 0 solution. Now understand this. It is already given that it has non-zero solution, but by assuming that we are able to say that it is having zero solution, which means there is contradiction. Therefore, what can we say? We can say that definitely determinant of A has to be 0. Okay, are you able to understand it? I'll again repeat it. See this. Whenever you have to satisfy necessary and sufficient conditions, generally P and Q will be given. If P, then Q, that kind of question will be given. Then necessary condition means you have to assume that P is true, and then derive that if P is true, then Q is true. What is that I am trying to do here? I'll assume that P is true, and then I'll assume that Q is not true. Okay, Q is not true, and then this one turns out to be false, which means Q has to be true. So here what I did is, what are we supposed to prove? If this equation has to have a non-zero solution, then determinant of A has to be 0. That is what we are supposed to prove. Then what I took is, I assumed that determinant is not equal to 0. When determinant is not equal to 0, this condition is failing, but we have already seen that this condition is true. How is this condition failing? If determinant is not equal to 0, then definitely rank equal to n. If rank equal to n, we know that the system has unique solution, and that solution is 0 solution. But we already have taken the claim that the system has non-zero solution. Therefore, what can we derive from this? We can derive that if Ax equal to 0 has non-zero solution, then definitely determinant of A has to be 0. Therefore, necessary condition is proven to be true. And what is the next thing we should prove? Sufficient condition. Okay, I'll erase this and prove it. Sufficient condition. Now let's try to prove this sufficient condition. So what is sufficient condition mean? You have to take Q to be true and show that P is going to be true. Now sufficient condition. Observe the way I am writing it. Okay, sufficient condition means we had assumed that Q is true. So what does it mean? If determinant of A, I am just writing this entire matrix as A. If determinant of A equal to 0, then what should we prove? Then Ax equal to 0 has visible red. Then Ax equal to 0 has non-zero solution. Okay, this is what we are supposed to prove. So what is that? If determinant equal to 0, then we are supposed to prove that Ax equal to 0 has non-zero solution. See this. Now if determinant of A equal to 0, A is a n by n matrix and determinant of A equal to 0, then what can we derive from that? Definitely rank is less than n. That implies that rank is less than n. Why? Unless you find out the determinant is not equal to 0, we cannot make rank equal to n. If the determinant of this matrix is 0, definitely rank has to be a number less than n. Now rank is less than n. Now what do we know by this? Whenever we have such a condition in linear homogeneous equations, this is applicable only for homogeneous equations, not for non-homogeneous. This is a homogeneous set. Now what can we say? For this one, the number of linearly independent solutions is n minus r. So n minus r linearly independent solutions are possible. Okay, and when we have at least one linearly independent solution, it cannot be 0. No linearly independent solution can be 0. Therefore, what can we say? Then we can say that it has at least one non-zero solution. Done. That's it. Simple. So what is it? We have taken this fact that determinant is equal to 0. Then what did we derive? That the rank has to be less than n. If rank has to be less than n, then it is going to have n minus r linearly independent solutions, right? Then what can we say? If that is the case, then Ax equal to 0 will have non-zero solutions. Therefore, we are able to prove, fully sufficient. See, the question is simple. What I want you to learn is how to prove these necessary and sufficient conditions, because later in some other subjects we might even use this concept. So what is it? Remember this. Whenever two conditions P and Q are given, if you have to prove that P is necessary and sufficient condition for Q, then we are supposed to prove it both the sides. What does it mean? Assuming that P is true, we have to derive that Q is true. Okay, and what is the other one? Assuming that Q is true, we have to derive that P is true. If you can do both of them, then it is nothing but necessary and sufficient conditions are proven, right? And what is the method I followed in this case? I assumed that P is true, and then I assumed that Q is false, and then I shown that if Q is false, P cannot be true. But already since we have assumed that P is true, this has to be true. That is the method I used. So please watch this 3 times. If you didn't understand it in the first go, probably in 2-3 times you'll understand it. Even though such question will not be asked directly in GATE, it will be important for you in interviews. This is asked in IAS. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have, you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.